Okay, so you guys should be able to see that I have instructed you on the very first page of your notes to do 1 through 27, the odds, and all I wanted you to do was to find the partial derivatives. So you shouldn't be surprised to see from 7.3 these problems. They do have different instructions, and I want you to ignore those instructions, and all I want you to do is, here's my answer key, find f sub x and f sub y for each one of your problems. Okay, if you can't read them, shoot me an email. I'd be more than happy to give you problems directly out of your book. So let me show you exactly what I want you to do, because I like to not only talk about the first partial derivatives, but also the second. Okay, so here's problem 1 from your homework assignment. And for your homework, I asked you to find f sub x. So let's see, this has an x in it, 2x. This does not, 0. This has an x in it, plus 4. This does not, 0. That does not, 0. So there you have it. F sub x equals 2x plus 4. F sub y then equals, okay, no y, 0. This one has a y in it, negative 6y. This one has no y in it, so we're going to leave it alone. It's 0. It's a derivative, it's 0. The derivative of 6y is 6. And then the derivative of 8, there's no y in that either, so its derivative is 0. So that's all I'm asking you to do for that homework assignment, and you should see that the very first answer from what I've provided is the same thing as what I got here. Okay, so please ignore the homework instructions out of the printouts that I gave you, but instead just find the partial derivatives. Now, what I'd like to do now is talk about second derivatives. So what does a second derivative look like? All right, so when you find your first derivative, this is labeled as df dx, or f sub x. This one is labeled as df dy, or f sub y. So what would happen if we did f sub x, which is labeled as d squared f dx squared. All this is saying is that you're trying to, let me zoom in on that, okay? You can find this notation in your book and also online. Okay, just do partial derivatives, second partial derivatives. They'll show you this notation. Okay, so all you're trying to do is take two derivatives, paying attention to x twice, right? The top part says take two derivatives. The bottom part says each time you're paying attention to x. Now this is how I do it. I always work from the inside out. And the first two are going to tell you where to go. So the first two says go up here to f of x right there. And pay attention to x again. All right, so here we go. Derivative of 2x is 2. Derivative of 4 is 0. And we're done. Okay, let's now try f sub y sub y. The notation on this, d squared f dy squared. So this says take two derivatives of your function, both times paying attention to the y. All right, let me try to color code this so that you can follow along. You always want to go to the first two, the first inside. This says go up here, so you're going to go all in here. It says take another derivative, pay attention to y again. So if you're paying attention to y, the derivative of this first part equals negative 6, and the derivative of the last part is 0. Okay, so again, the inner two always tell you where to go, the outer one tells you what to pay attention to. All right, so we need to also, I'm going to rewrite this function down and its first derivatives. So let's see, we have f of xy equals x squared minus 3y squared plus 4x plus 6y plus 8. And the reason that I'm doing this is that I've got too many things circled. fxx is equal to 2, fyy equal to negative 6. All right, so there's two more second derivatives. There's actually 4 in total. Okay, so this is d squared f dx squared. Two derivatives, both with respect to what? X. This is d squared f dy squared. So then the question is, well, what if we have f sub x sub y, right? So in this case, what you do is you circle these two that are on the inside because that tells you where to go. This says go here. But when you take the derivative, you pay attention to the y's. Notice there's no y here, there's no y there either. So 0 and 0. So this is just 0. Okay, the notation on this is kind of counterintuitive. It's d squared f dy dx. Now the reason that that's the case is the one that's closest to your function. If f were out here instead of above us, it would say take the derivative with respect to x, and then later on take the derivative with respect to y, which is what this is indicating. Okay, let's try the last one. So d squared f dx dy, which this is shorthand f sub y sub x. Okay, let me show you where to go. Circle the inside, and you go here, and you pay attention to the x's. All right, so we're right here, right? No x there, 0, no x there, 0 as well. Now it turns out that these two will always equal each other, and you do need to keep that in mind because it'll save you some time. F sub x sub y and f sub y sub x are always equivalent to each other. I couldn't tell you why that is, but I'm certain you can look that up. Okay. So I have given you the task of finding the second derivatives of many of those exact same problems from 7.3, and you'll notice I gave you the solutions for that. Okay, so I'm going to do a couple of those before I end this video. So why don't we start off with problem number 11, and we'll just start from the very beginning and work our way through the first and the second partial derivatives. All right, so problem number 11 reads f of xy equals 3x squared minus 6xy plus y cubed minus 9y. All right, so I asked you to find the first partial, so f sub x and f sub y. All right, so this first one says go up here, pay attention to the x's, 6x, right? Oh look, this has an x in it too, minus 6y times 1, right? Pull out the 6, pull out the y, which is constant. The derivative of the x that's left over is 1. Okay, this one doesn't have a y in it. I'm sorry, it doesn't have an x in it, so its derivative is 0. And this also doesn't have an x in it, so its derivative is also 0. So the partial with respect to x is 6x minus 6y. 6x minus 6y. All right, if we took the partial with respect to y, this would have to be 0. It does not have a y in it. So here, this has a y in it, so you have to be careful. So you pull out the 6 and the x, and the derivative of this y that's left over is 1, plus the derivative of y cubed, 3y squared, minus the derivative of 9y, which is 9. So this equals 6x plus 3y squared minus 9. All right, let's get to the second derivatives. So f sub x then equals, this says go there, right? Put my finger on it. Said pay attention to the x's. So if I'm paying attention to the x's, the derivative, I'll go here. The derivative of 6x is 6. The derivative of negative 6y, there's no x there, so its derivative is 0. Okay? So let's do f sub y sub y. Okay, this one tells me go there. Let me put my finger there so that you can keep track. It says pay attention to the y's. Right, so I'm going to go over here. Derivative of 6x is 0. Derivative of 3y squared is 6y. And the derivative of 9 is 0. Okay, so I don't have to write that down. All right, so here we go. F sub x sub y, which I'm going to use this blue pen to show you where to go. It says go here. I'm going to put my finger on it so that you can see where I am. Hold on. There you go. It says go here and pay attention to the y's, right? The second one tells you what to pay attention to. So I'm going to use this version of it. Derivative of 6x is 0. There's no y there. And the derivative of negative 6y is negative 6. Okay, one more. So for our last one, why don't we do f sub y sub x. Now this says go to f sub y. Let me show you where I am going. I'm going right here. Right? So it's going to be kind of hard to see. There we go. Right? And it says look at whatever f sub y is and pay attention to the x's. So I'm here. This has an x in it. Ooh, I made an error. And how could I see? I saw it immediately because my f sub x sub y is negative 6, which means this has to be negative 6 also. Look, I dropped a negative. Right? So you can always check your work fairly quickly. So if I'm paying attention to the x's, this should be negative 6. This has no x in it, so its derivative is 0. That has no x in it, so its derivative also is 0. Okay, so that was a good one. All right, let's try problem number 17 and then we'll call it quits. Okay, so for 17, we have f of x, y equals x squared minus 2xy plus 4y cubed. Okay, so f sub x, wait, this has an x in it, good, 2x. This has an x in it, negative 2y times 1, right? So the 2 and the y are constant, and we can take the derivative of the x. The derivative of this doesn't have an x in it, so its derivative is 0. Okay, let's do f sub y. No y, its derivative is 0. This one has a y in it, so we're going to pull out the negative 2 and the x. And the derivative of this y that's sitting here is 1 plus, this has a y in it also, 12y squared. So f sub x, this one says go to f sub x. I'm going to put my finger where I need to go, right here. It says pay attention to the x's. Well, the derivative of 2x is 2. This doesn't have an x in it at all, so its derivative is 0. Okay, f sub y says go here, right here. It says pay attention to the y's. This doesn't have a y in it, its derivative is 0. This has a y in it, and its derivative is 24y. All right, let's keep going. F sub x sub y. Okay, let me show you where to go. Here. Pay attention to the y's. So this doesn't have a y in it, its derivative is 0. This one does, so its derivative is negative 2. And then finally, f sub y sub x says go here. Pay attention to the x's. Look here. This one, derivative is negative 2. And the derivative of this has no x in it, so its derivative is 0. And look, these two end up being the same. So I know that I'm on the right track.